Hello viewers, so we have this question under chemical kinetics. It says if the initial concentration of the reactant is doubled, the time for half reaction is also doubled. Then the order of the reaction is. So we are told to determine the order of the reaction by comparing the initial concentration and half-life of the reaction. So let's quickly do that. What we are comparing is, we are comparing the initial concentration. Say we have A as our initial concentration, and we're comparing this to T half. So what they are telling us here is if the initial concentration is doubled, also the half-life of this chemical reaction is doubled. So what that means is the half-life is directly proportional to the initial concentration in this reaction. So what order has got that relationship between half-life and the initial concentration? So we need to list the half-lives for all the three orders of reaction. So for zero order, we'll start with zero order. So for zero order, our half-life is given as T half is equal to the initial concentration divided by 2K. That's for zero order. Then for first order, our half-life is given as T half is equal to natural log of 2 divided by K. And then we have for second order, what we have is our T half is equal to 1 over K multiplied by the concentration of A initially. Yes. So those are the three half-life equations we have starting from zero order, first order, and second order. Now we need to determine the order of this reaction in this question here by comparing T half and the initial concentration. Already on the first order here, we can see the T half equation or the half-life equation doesn't have any initial concentration. So this reaction we have in question here is not first order because the T half is not related to or affected by the initial concentration if the chemical reaction is first order. Yeah. So it means it is only affected by the initial concentration if a chemical reaction is zero order or second order. As we can see, in second order, we have the initial concentration. Also in zero order, we have the initial concentration. But then let's determine the relationship for zero order. When you look at this here, we have our T half here, and this is equal to the initial concentration on top and then divided by 2K. Now, if you have something on the other side of the equal sign, let's say our T half here, and then you have a fraction on the other side, what that implies is what is on top of that fraction, or rather, let's say the numerator is directly proportional to what you have on the left-hand side on top as well. So T half in this case is directly proportional to the initial concentration here. What that implies is if we increase the initial concentration, the half-life also increases. If we reduce the initial concentration, the half-life also reduces. So this relationship is called directly proportional or direct proportionality between the two. This one increases, that one increases. If this was down here, it was going to mean these two are inversely proportional. When you increase the other one reduces. So that relationship is here. We can see our initial concentration is down here and T half is on top there. What this implies is these two are inversely proportional. When we increase the concentration of the reactant in second order, our T half will reduce. And when we reduce the concentration, our T half will increase. So the relationship we're talking about in this question is zero order, because when we double the initial concentration, the half-life also doubles. So our answer here is the reaction is zero order. So what we should know is if the reaction is zero order, increasing the initial concentration will also increase half-life. If it's first order, increasing or decreasing the initial concentration doesn't affect half-life. And then in second order, the relationship is inverse. When you increase the concentration, T half reduces, and when you reduce, T half increases. Yes.